Hello physics, wave nature of light, dispersion of light. This is the topic. The problem is a light beam enters a piece of glass at an angle of 60 degree. The beam contains two wavelengths, 450 nanometer and 700 nanometer, for which the refractive index of the glass is 1.4820 and 1.4742 respectively. What is the angle between the two refracted beams? So this is a piece of glass. This is a normal, and this is the beam which enters at an angle of 60 degrees, and then it has two components. So this is a straight path, but it will go toward the normal. So this one and this one. So this one is theta, say theta 1, and this one is theta 2. So this is beam 1, this is beam 2. So we have to find the, no, this is theta 1, this is theta 2, and this is say theta 3. And we have to find this one in between two beams, theta 2 minus theta 3. So this one is N1 and this is N2. N2, there are two components, N2, this beam and this beam. So we have to use the Snell's law. Snell's law, which is N1 sine of theta 1 is equal to N2 sine of theta 2. But there are two wavelengths. Wavelength is 450 nanometer, and another one is 700 nanometers. This has a refractive index, and this has a refractive index 1.4820, 1.4742. So N1 sine theta 1 is equal to N2 sine of theta 2. N1 is 1 sine of 60 degrees. N2 is 14820, and sine theta 2 we have to find. Theta 2 is equal to 35.70, and this one, if you apply N1, sine theta 1 is equal to N2, and say this is 2, this one, and sine theta, say it's 3, sine theta 3. So 1 into sine of 60 degrees into 1.4742 into sine of theta 3. So from here we can find theta 3 is equal to 35.98. So we have this, so theta 3 minus theta 2 is the angle between them, 35.98 minus 35.70, this is 0.22 degrees. So this is delta theta, the refractive, the angle between them, these two wavelengths. So this is the answer of this question.